So let's welcome Peter.
Appreciate the introduction. All right. Thank you for coming. Today I'm going to be talking about some non-obvious complexities when building software, especially in IoT projects. A couple of housekeeping items. Feel free to interrupt me whenever you feel so, okay? I know everybody says that, but I actually mean it, okay? You guys never do it, but please do it now. Whenever something is confusing, you would like to hear more about a certain topic or whatnot, let me know, raise your hand, and maybe there's a present waiting for you over there. So I got a very nice intro, but a couple of things about myself I probably shouldn't here. 2 decades of software engineering, my gray hair sort of dates me. However, 2 decades is a long time. I started building software back in Palm OS days. Who knows Palm OS? Anybody heard of this? Okay, amazing. So that was when I wrote my first commercial line of code. And over the years, obviously the operating systems evolved. We had Symbian OS, Windows CE, all that jazz. We started building midlets on Java, and then iOS and Android came around, and we're here sharing interesting learnings out of this journey. So I work currently at Intent. Intent is a software engineering consultancy which focuses on what we call intersection of physical and digital. What I mean by that is pretty simple. So whenever a project has a tangible manifestation, like a physical manifestation, it's our sweet spot. So think of this intersection of physical and digital as something that I can show to my mom and she'll get it, right? Because back in years ago, I tried to pitch my mom a SharePoint extension that I built. She had no idea. But when I show her an Apple Watch running something, she will get it, right? So that intersection of physical and digital is our specialization, and we've been very fortunate to work with some amazing companies, starting from Aura. You guys know Aura, all the way from like Aura Ring to Bose, the headphone company. We also had an episode working for Maserati. So all across form factors, sizes, and projects. I'm a mentor. I help startups define their technical strategy in programs like Google for Startups, or one that's actually based here called Plug and Play Villages. And then, like the great host said, I run a podcast on Hackathon. If you need help pitching, hackathon to your manager, talk to me. I have been selling podcast hackathons forever, and I really think it's a great opportunity for engineers to grow in a very short amount of time, sacrificing a little bit of health. 2 more tidbits. I'm an ex-VC. I have invested in startups for a little bit, and I also had my own startup, which exited afterwards raising funding. So I do have perspective of both sides of the table, so start at the table. Before we dive into the nitty-gritty details of the complexities and mitigations that I would like to talk about, I wanted to give you a little bit of context on why I'm even talking about this topic. So I like to call these standalone apps. When you're building software that just runs on the phone without talking to anything outside, be it a server or a device, these apps are relatively simple. And I know you guys are in software, and I know it's not simple, but if you compare it to something that talks to a peripheral, these standalone apps where you only have to worry about what's going on the phone are relatively simple. And everybody starts with those standalone apps, right? And then we add complexities, right? We start interfacing with various system services, still constrained to the phone, right? But there's more complexity. So we start talking to the server, right? And When talking to a server, a lot of things can go wrong, as you might imagine. You guys know this very, very well. Thankfully, when talking to the server, we have a very well-defined ways to do so, right? We have the REST APIs, we have sockets, we have GraphQL. A lot of those things are very well-defined, right? And the number of things that can go wrong is almost infinite, but we can probably very well predict what can go wrong. Whoops. So things are dramatically different when you're building for IoT. When your app graduates from being a standalone app that just runs on your phone to an app that we call a companion app, right? So your app accompanies a device. It's usually a window into this device because more often than not, these devices don't have screens, and the only way to talk to this device, to control this device, or to get value from this device is your app, right? So all of a sudden, when you enter this setup, you don't have one, but you have two devices to worry about, right? And things can go wrong on the host device, on the iPhone, and things can go wrong on a wearable, or a smart speaker, or headphones that you're connecting to. And the problem with these complexities is they don't add up, but they multiply, which generates a lot of headaches for engineers or teams who haven't been exposed to building apps that interface with other devices. And over the years, we have seen small startups and major companies get burned by those complexities that I'll be talking about today. And with startups, it's an expected result, right? I consult for many startups, and the expected outcome of a startup, averaged out, is going to die, most likely. 90% of startups fail for many reasons. Some of those reasons are very related to technology. But when you try to extrapolate and understand why big companies, oftentimes Fortune 500 companies, major companies that have essentially unlimited resources, unlimited cash, they get burned by those issues as well, just as little startups. And as a fun fact, well, not necessarily a fun fact, but I'll tell you that we personally, as Intent, my team, we have witnessed a major Fortune 500 company axed an entire division from their corporate structure because they had so many issues with pairing the device that the board just decided they don't want to do it anymore. So what I'm trying to convey is these little problems that we're going to be talking about today often have a lot of impact. And in this specific case, they cost jobs probably a few hundred people. That's how hard these problems, escalate, like bubble up to. Now, this is a real statistic. So, and it comes from one of our partners. And I'll read it out for you because I think it's really important and it really brings up the core of what we're going to be talking about. Up to 70% of returns are caused by issues with connectivity. Think about this for a little bit. 70%. So vast majority of the returns are generated by people who are not able to pair the device or connect to the device once it's paired, get the data off the device or configure the device. And when you think about, so if you're not in like a physical device business, the returns might not sound very painful, but when you're selling a physical device, a return is not only the missed opportunity that you don't get selling your product, but it's also logistics, it's credit card fees, it's time of your team, it's the brand damage. There is a whole slew of things. There's a chain, like an entire chain reaction that happens when a customer decides to return the product, and they return it because of issues with connectivity for the most part. So that's why I'm doing this talk. Not sure if you want to read it. I'll get out of the way. Some of these, so these are reviews out of Google Play for a specific device. I try to anonymize it, not to like point fingers. But I think this really illustrates the problem well. Because these guys, I'm not going to name names, but these guys had a real good product until they decided to make it smart. And when they did, they got surprised by all these issues that we're going to be talking about today. And that's the result. Had they not decided to put, this is debatable, right? I personally think that sticking a Bluetooth chip in every device and making a companion app doesn't really make sense. You really have to work hard to prove the value of the product. But if you decide, or your manager decides, to make a product that you're working on smart and have a companion app, recall this slide and make sure that you guys come up with a good enough value prop to justify the cost and the risk that this carries along. All right, long intro, but bunch of complexities and mitigations. First and foremost, vast majority of the peripherals and IoT products, they are powered by wireless protocols. And there's a lot of them, right? There's Wi-Fi, Zigbee, LoRa, NFC, tons of them, right? And when you decide on utilizing either one of these or a combination of these, because for more complex IoT devices, you end up with doing Wi-Fi and Bluetooth in parallel almost. You use Bluetooth to onboard the device to the Wi-Fi. And you really need to be thoughtful when it comes to limitations of these protocols that you're using. One example where this went south, how many of you guys had a Fitbit? Okay, so you'll probably know what I'm talking about. Fitbit, when Google acquired them, the main connectivity, well, the only connectivity way that Fitbit offered was Bluetooth. And software update for Fitbit took roughly 25 to 30 minutes over BLE. The problem is, typically, I spent roughly half of my afternoon trying to get that OTA across because I would get a phone call on my phone, which derails the process. It puts the app in the background, and you're not able to transact the OTA image. I would get distracted. My phone would go into like a sleep mode, which also breaks the process. So just this example shows you that if you don't take into considerations those limits of the protocols that you're using, you will make it really hard for the user to use your product, right? Another good example is Bluetooth, but in an audio space, right? So like most of you probably have headphones, those noise-canceling headphones. And the problem with headphones is that they typically use two flavors of Bluetooth. There's Bluetooth Classic, which is kind of a legacy Bluetooth. We all know Bluetooth, for audio streaming. And typically, at least on iOS, you pair Bluetooth on the Bluetooth Classic on the system OS layer. So you put the headphones in the discovery mode, right? So they start advertising. And you pair them through settings, right? Well, nowadays, these headphones, they are also considered smart, and you can tweak various settings through usually a companion app that offers you to, toggle various settings of the equalizer, configure your noise canceling, things like that. And you push those settings through to the device from the companion app, not over Bluetooth Classic, but over BLE. So you just paired your headphones through Bluetooth Classic. You fire up the companion app, and now you have to pair again, which doesn't really make sense, right? And Probably those of you who understand Bluetooth and know Bluetooth will raise the hand and say, hey, Peter, there's Bluetooth Classic Profile, which is called SPP, which stands for Serial Port Profile. The problem with this is because of another issue that I'll raise in a second, you cannot use it really on iOS because it's restricted. In order to use SPP on iOS, you have to go through Apple's MFI, Made for iPhone program, which is very expensive, very tedious, it takes a lot of time, and the best of all, you have to pay Apple a cut of your MSRP, like the shelf price of your device, for using Made for iPhone logo or stamp. So if you would like to make life easier for your users, you have to pay up to Apple to use that protocol. And these examples, I can multiply these examples over and over and over again. But the fact of the matter is, you really, as an engineer or as a product person, you really need to be aware of the protocol envelope that you're using and navigate it so that user is not surprised or confused or things like that. We talked about protocols, now we have to talk about platforms. Thankfully, some of these platforms died off, right? So we had WebOS, right? Remember that? Or Windows Phone. That's dead as well. So now you have two leading platforms that cover a vast majority of the market. The problem is that these platforms, even though they are relatively similar in form factors, right? You know, most of the phones now they're just a slab of glass displaying things, but they very much differ in ways they handle various things. And back in the day, you know, decade ago, when I started doing some Android development, you had differences in magnetometer readouts from the various vendors. So one would show true north, one would show magnetic north. It was really confusing. It's a little bit more standardized now, but you still have to understand and keep in back of your head the differences between how iOS handles Bluetooth and how Android handles Bluetooth, because they do handle Bluetooth relatively differently. One more interesting example from the audio space is, you guys know the wireless headphones. Some of them have tap to pair, you know, like the NFC, based on NFC. And on Android, it works relatively well, right? You tap to pair, they do a little bit of magic, and boom, your headphones are paired, at least through Bluetooth Classic. On iOS, you don't get access to that NFC chip, so you cannot do, like, iOS doesn't offer tap to pair through NFC. And the problem is, you might imagine, you know, we as technical people, we understand, we get it, right? People like an average Joe in the United States, he's going to pick up those headphones with his iPhone, go home and try to tap to pair through NFC. And he's going to be frustrated because, you know, what the hell, my you know, Apple Pay works very well with my NFC. Why don't these headphones work? And usually they will default and blame the vendor or, you know, the manufacturer. So that's another thing, another complexity to keep in mind. And also something, you know, like an extra kicker for, you know, for you guys as people building these things is these operating systems are not really consistent across the major versions, major releases, for instance, of iOS, right? So you will have different APIs and different permissions to handle Bluetooth on iOS 17 and iOS 18. As a matter of fact, Apple, with iOS 18, that's coming out probably in a week, they're releasing a new framework for pairing accessories, which handles things dramatically different from what it was before, right? Before you had to, like, tap allow for the system prompt. Now you'll have a little bit more of an experience that resembles the AirPods, how AirPods pair. But the fact of the matter is, you, as an engineer or a product team, have to remember this. I like this one. It's very counterintuitive, but when building software, and this is really a universal silver bullet advice, when you're building software, please focus on the hardest problem first. I'm bummed by, and I get where it's coming from, right? But it kills me when teams sit down and work on things like authentication flow, or settings screen, or terms of service, right? All these things that come really, really easy, quickly, but they neglect things that are really, really hard, like pairing or making sure that your Bluetooth works well in the background. These things get pushed down the backlog. And even though I also sometimes understand how it feels from the customer standpoint when your team, after a sprint, is able to show, hey, there's this whole onboarding flow. Look, you can now create an account. But the problem is, these hard things, down on the bottom of their backlog, they will bubble up. And usually, engineers are really bad at estimating projects. I'm not that great at estimating projects. So whenever you can, focus on the hardest problem. Do a lot of spikes. I feel that those spikes in like Jira and Scrum, not a lot of people are using them or have like a habit of doing spikes or doing little POCs to test out various hypotheses. Please do that. Don't push the hardest things down your product backlog. Push notifications. We could probably do the entire talk on some of these slides by themselves. Push notifications are really hard. They are fragmented. iOS treats push notifications differently than Android. Certain versions of iOS have different ways of handling push notifications. Users have this syndrome called notification fatigue, right? So Apple decided that we need to shield users from push notifications and introduced settings like scheduled delivery, right? So now even I have ADHD, and I sometimes compulsively check my phone, so I had to limit my push notifications down to getting them in the morning and after work, and it works great. But the problem is a lot of apps rely on push notifications. So push notifications are, some of them are, they notify you that the message came through, but a lot of engineers or teams use push notifications as a way to wake the app up from the background and do something, like synchronize something from the server, or try to wake the app up and do like a little Bluetooth transaction underneath, which is great because those, by the way, those push notifications are silent. They don't manifest themselves as a little banner or anything. But again, the problem is you will be, if you build features that are so dependent on push notifications, you will crash and burn because there are so many things unexpected, like those scheduled deliveries, like power saving mode on iOS, like people going out of range of cell phone signal. You really have to be careful when embedding push notifications into your business logic, other than obviously notifying user about something. That's another one I really like. And we have explored this topic on so many projects, and it's really hard to tell the client who is not technical, the way background execution works nowadays in phones, and this applies both to iOS and Android. I'm comfortable to say it's very non-deterministic. You don't get any sort of warranty. And by the way, that applies to push notifications as well. So neither Apple or Google will give you any guarantee on delivering the message to the user. Most of them, they get there, but nobody will give you any sort of guarantee. And with background execution, it's even harder because there are multitude of things that can affect the decision of the operating system to whether or not give you an execution time in the background and how long of that time chunk you will get. And it depends on so many things. So there are multiple WWDC talks that try to explain this problem. And when you watch them, you get more confused. It's mind-blowing. So you might not get execution time if user is running low power mode on iOS, the setting. You might not get execution time in the background if user has too many apps open, right? Or if they're using music, which also overloads the system. So I guess what I'm trying to say is treat this as a nice to have and not build features or products that rely on this heavily. And we got crashed and burned by this because we've been working with a company which had a wearable. And the wearables, as with most wearables, they are incredibly underpowered, right? So the transaction, when you're downloading data from that wearable, took roughly 3 minutes, right? And when I say 3 minutes, 3 minutes, when it ticks here, it's ages, right? When I say to you 3 minutes, it's short, right? But when 3 minutes are articulated by the progress bar on your screen, it's so long. It's incredibly long. So we tried to utilize background execution, but it turns out more often than not, we failed to get data from the device. Some of our team members even tried to, they were so ambitious that they were like, okay, in the background, we're going to download stuff from the wearable, and we're going to push it upstream to the server. That didn't work. And so treat this as nice to have, but also, if you're trying to do stuff in the background, there is a whole slew of things that you need to implement and worry about that you wouldn't otherwise have if you didn't utilize. For instance, you need to properly implement guardrails that will prevent the data corruption. So if you're in the background and if you're pulling data from BLE wearable, the OS can kill your app anytime, and you're not getting any sort of warning. So you really need to implement proper data integrity checks and make sure that the data is safe once you pulled it off, a smartwatch or Ring or whatever, before you transact back to the Ring and say, hey, I got this. This probably shouldn't be a surprise to most of you, but again, the more I work with a lot of vendors, the more I lose trust in any sort of specs, documentation, right? So if you're working with an API and someone tells you it can handle X amount of API calls, right, per second, fixing this is much easier than fixing a piece of hardware that integrates into your hardware and has libraries that don't work as advertised. And we worked with probably most of the well-known chip vendors, and you would be surprised by how terrible some of those libraries that they provide are in terms of quality, documentation. So just to give you an example, there's a leading chip provider that has a library that controls a system on a chip that they offer. And that library is being worked by a Chinese ODM, which makes sense, right? They manufacture it there. They have a Chinese vendor. And They don't have a repository where they store it. At least they don't offer it to people like us who integrate their solutions. They have some documentation, but it's outdated. The way they send you updates is they send you a link to Google Drive. And you pull it off, you integrate it in your project, and it turns out a lot of things don't work because some of the interfaces have changed. And there is no version control whatsoever. You don't know how many versions ahead is that Google Drive file that you got. It's crazy, but it's also crazy to me. It's 2024, and we are still doing things that way. The worst of all is when you try to request a change, hey guys, this doesn't work, or we're having problems with this, you have to talk to a Chinese vendor, and the turnaround is a couple of weeks. And if you don't account for this in your project timeline, it gets derailed. At one point, at Intent, we had a guy in our office in Poland who spoke fluent Mandarin, and probably 6 hours out of 8-hour day was him sitting on WeChat and talking to Chinese vendors of various chips, trying to communicate. Is that crazy? That sort of builds on top of the previous slide. So theoretical versus practical range. When you pull up Wikipedia and look what range does Bluetooth has, or BLE, or LoRa, they will give you numbers. But these numbers are, as you may imagine, they are reflecting an ideal environment. And we're never an ideal environment, and even worse, with all those wearables. I'm going to stick to wearables because we do a lot of wearable projects. With these wearables, they are A, underpowered, and B, they have tiny antennas. And C, they're usually mounted somewhere around our bodies. And as you know, our bodies are made from roughly 80% of water, which is really good at blocking RF signal. So we worked with a company that had a very interesting, it was a medical wearable that goes into your ear. It's like 2 grains of rice, tiny. And they had problems because you were supposed to wear it in your sleep. When user rolled around on their side, they were blocking the RF signal, so it couldn't go through. And you really have to account for these because it's not even the fact that we're good at reflecting or blocking RF signal, but it's also surprising to users who are used to, having their AirPods on their head and talking and wandering around the entire house, and it works. But if you have a tiny wearable and you sit it on your bedside table and go to the bathroom, the odds are your phone will not see it because of the tiny antenna and because of the amount of power that it gets. Licensing and compliance. I don't want to bore you guys with a lot of legal stuff, but please remember to check licenses of the dependencies that you're using. It's really important, and it's usually the lawyers who do a due diligence process after the software is built. They discover that this and that library that you're using, you cannot be using it because of licensing issues. Some of those licenses or software quality is incompatible with environments that are regulated. So if you have a wearable that aspires to be a medical device and you want to clear it through American FDA, there are some libraries that will basically derail the entire process. And while we're at compliance, before you start writing code, try to understand what you're building. And I'm not talking about the feature set, the UI, the UX, but try to understand where this product will end up, because the likelihood of some regulation applying to your product is really high. So it's either medical or it's GDPR. There's tons of regulations, and the regulatory envelope is really complex, both in Europe,
where we have, people trying to regulate that stuff, which is crazy, but in the US as well. So I'm not going to spend too much time on this, but again, please remember, if you're using Bluetooth, right? So if you have a wearable that uses Bluetooth, iOS, so if you're building apps for iOS, you have core Bluetooth, right? You have Bluetooth APIs. But if you're releasing a product that has Bluetooth in it, like a physical product, you have to certify it with Bluetooth SIG. And there's a lot of organizations. So if you're using any sort of standard, the likelihood of it being backed by some organization, and that organization usually has an accreditation or certification process that is probably not tedious, but it takes time. So keep this in mind. UX is insanely important. Probably I'm saying obvious stuff, but, and I said it before, a lot of those wearables and a lot of those devices that you're building apps for, they don't have screens, right? So this ends up being the only UI that you talk to the device through. And if you don't do a good job explaining certain things to the user that we just talked about, right? So like permissions, so they're not surprised, to pair the device twice, and all the other quirks, you will be probably generating the returns. Because the UX is poor, people will get confused. And if they get confused, in Europe, it's not really that popular to return stuff, but I think it's sort of gaining momentum. But in the US, you have no questions asked policy on almost everything for 14 days, sometimes even longer. And people test drive devices. So the moment they get confused or you're not doing something that you said the device will do, they will return it. And really, the returns can kill your company. Security, important one, right? And it's very contradicting to a lot of startups, right? A lot of startups are like, move fast, break things, and the security is the last thing that they consider. But with wearables and devices, there's a ton of really sensitive data that my Apple Watch, holds on me, and I probably wouldn't like it to leak out somewhere. And I'll give you one example, which is sort of obsolete because with the new iOS 18, this is addressed. But we built an app for a wearable, and one of the requirements of the American FDA, the Food Drug Administration, is that every piece of software that will be a medical device gets pen tested. So there's a red team basically sitting for 2 weeks and pounding on this device and everything in between the phone and trying to break the encryption and whatnot. And what was interesting, they noticed that the BLE packets, as they arrive on the phone, they get decrypted on the phone level, on the OS level, not on the app level. What does that mean? In a very specific case, when you have a malicious app installed on your phone, it can eavesdrop on the communication between your wearable and your app without you knowing. Of course, Apple has their measures, their approval process for apps, but still, things like malicious apps sometimes make their way to the App Store. And if you didn't care about security, you probably would have had a big problem once that device got through the entire FDA process, and if it didn't pick this up. Because there could be real attackers eavesdropping on really sensitive data that's going between your phone and the wearable device. More suppliers, more risks. So typically now we see a lot of IoT devices get there's tons of chips inside, and the more your BOM, your bill of material grows, the more potential problems you'll have. So remember when I talked about those libraries? The more chips, the more sensors you get, the more time you really need to dedicate towards making sure that everything works as advertised. And the problem is, it doesn't. So make sure that you keep this in mind when building stuff. I talked about the most important and the hardest problems to solve first. This is probably number one thing you should be working on when building an IoT device or a wearable, an OTA. So a mechanism that allows you as a vendor to update the software on the device side and do it relatively painlessly, right? So a few gotchas there. Not everybody updates, right? So again, it's on the UX and you guys to incentivize the user to update, but also make sure that they understand that it's crucial to update. It's a fragile process, right? We talked about Fitbit. A lot of things can go wrong when transacting a big firmware image from the phone to the wearable. And you probably remember devices that get bricked when updating firmware. Now we have a lot of mechanisms to prevent device bricking, but still, this is something on you or your team or your firmware team to implement. It doesn't come out of the box. And finally, this is a nice segue from security. We talked about security. You need to make sure, and it's on you, to make sure that the software or the firmware image that you're downloading to update your device with is downloaded from the safe place. So you need to validate if the server XYZ is actually the server that you own, that there is no man in the middle. I love Flutter. I hated React Native. And we made a very splashy exit out of the React Native as a company. But when you're building cross-platform apps, you really have to remember that you're basically getting some of the best of both worlds and a lot of caveats that these both worlds have. So for instance, we were building a Bluetooth simulator, which I'll talk about in a sec. But we tried to build it in Flutter, and the leading frameworks that Flutter has for handling BLE wouldn't let our phone be a central. So in Bluetooth, you have central and peripheral, right? And we couldn't get those frameworks to make phone act as a peripheral. So again, speeds up time, right? But especially in those really complex things like Bluetooth, you really have to do your homework and make sure that there are no things that can derail your engineering process by, for instance, not supporting certain Bluetooth features. I threw this in there. I don't even know why. You guys probably know this. This is a nice framework topic. Languages and frameworks don't scale. Architectures do. So don't focus on convincing your friends that X, Y, and Z is better than another framework. How many of you know Peter Levels, the guy on Twitter? He's pretty famous. No? Okay. So this guy makes roughly 6 figures a month with his startups. He's a maker. And he's an advocate. He went on a bunch of podcasts lately. And he's an advocate of doing things very, very simply. So he runs massive startups off a single VPS machine that is running on PHP and jQuery. And he gets all these laughs and hates on the internet, but he makes really good money and he knows what he's doing. So don't spend too much time thinking about these things or trying to use the latest and greatest, because some things just work. Some things that work. Don't spend a lot of time because there's just another shiny thing out there. Optimize for my happy paths. I think I've talked about this for relatively long now, but the default state of your app is not working, right? So, and you should really design for this. You should design for empty screens. You should design for users getting confused with permissions and saying decline when you're asking them to use Bluetooth. You really have to handle all these unhappy paths. And there's a lot of them when you're building IoT devices. So make sure that you remember this. QA, order of magnitude more important when you have devices. You really need to understand, like everything we just talked about, someone needs to test. And manual testing is tedious, right? It's it's just a tedious job. Automating this is a project in itself. It's really expensive to do, end-to-end UI tests that verify if you got a push notifications, for instance, or push notification. So make sure that you dedicate enough time for testing whatever you build, because the odds are you probably forgot about something, and the QA will save your butt. Backward compatibility, I know, again, the latest and greatest is great, but there is probably a lot of users that you leave behind by targeting the latest iOS. So it's more of a business decision, but it's on you guys to advocate for a solution that makes most sense engineering-wise, right? So like I said, with the new iOS 18, there is a framework that configures your accessories. Literally, most of the iOS users update within the first week of the new OS shipping, right? And it's on you to advocate to your stakeholders, to your PM, to your CEO, that, hey, there's this new framework that we can use, and it's gonna get rid of, 50% of returns that we get because it makes it so easy to pair. That's on you. All right. Things get derailed, right? We talked about this. And it's also on you to make sure that you have plan B. I maybe have that slide because I'm proud of my team, because they do a lot of really clever stuff. So we had one project where hardware was massively delayed. And I mean massively, like 2 months. And they didn't want to stay idle, right? So they built an ESP30, ESP32, like this little prototyping chip. So they built a simulator that simulates the device that is delayed on ESP32 to unblock everybody. And this is not really unusual, because I thought they were like, hey, you guys, this is amazing. But it turns out, more often than not, that in hardware projects, you really have to fill in the gap with some prototype or some clever solution, because your hardware is delayed, it's not working, there's another iteration that's being shipped, whatever. But you really have to account for this, and you really have to have a plan B for a lot of things. Telemetry is king. Your users will tell you that it doesn't work, and it's on you to find out why. And I feel like with the standalone apps, with Crashlytics, we have a pretty good window of understanding into what's going on the user's phone. When you're talking to a peripheral, Crashlytics won't tell you that a firmware crashed, right? And there are tools that probably, there's memfault and all that, but we had to build our own telemetry system that logs everything that happens on the phone, on the device, and everything in between. So like the BLE packets that go back and forth. That's how, in certain cases that we tackle, that's how hard these problems are. And again, the user will never tell you, like you call them, you say, what are these steps to reproduce? Heck, your internal testers won't tell you that, right? Because it's tedious, right? To reproduce an issue, it's on you to understand why is it not working. A couple of advocacy slides. Technical debt is a tool. Don't let anybody tell you that it's bad. If you're optimizing for speed and in startups, everything, like speed trumps everything, use tech debt, but use it smartly. You can cut corners. You don't have to write tests, but you have to keep in mind that you skip that and eventually come back and fix it. Avoid reinventing the wheel. So, we talked about authentication, onboarding. There are open source frameworks that will do it for you. These frameworks have been worked on by numerous engineers, numerous UX experts, and they usually optimize like Firebase UI. You probably know Firebase, Google's Firebase, like the backend as a service platform. They have a UI, open source UI framework that you drop it into your project and it works. So really try not reinventing the wheel. I'll skip this one because it's regulatory. Last but not least, when you finish the project and you release the app to the App Store and your product goes live to sales, you will need to allocate a lot of time for support. And I was talking to a team a while back, and I was asking them, when are you guys going to release this product? They're like, hopefully never. I'm like, why? Because it's going to kill the velocity, right? Because now we can go fast. But once you release the product, you have users, and you really have to care about introducing dramatic changes into the product because they don't go easy. Nobody likes changes, right? So release kills the velocity. So make sure that you plan the project really well and allocate the time and do the early betas and friends and families releases. That is it. My throat is killing me, so I'm a dusker on most of the social networks. If you want to follow me, I'll be hanging out here anyway, so I prefer face-to-face than Twitter. If you want to check out what Intent does, it's not intent.com, but with Intent. Here's my little podcast, a little plug. And if you want to email me, that's my email. I check all my email. I reply to most. So that's it. Thank you for sticking around.
So thank you, Peter, for your insightful speech. So now we have 10 minutes for Q&A session. So do you have any questions? Basically, if you are too shy, you can just write it down in a Discord chat.
You can slide a little piece of paper, here and read it.
Okay.
Thank you. Actually, I have two questions. One about business and second about architecture. Which one should I start?
Whatever. Go with architecture.
Okay, so about the architecture was about push notifications. You said that sometimes app makers use push notifications and they are silent push notifications to wake up the app to do something in the background, and this is great. And for me, I'm not like app developer. For me, it sounds more like using the tool that was designed to deliver some information to user to wake up your application and do something. So if I was iOS platform developer, I would ban some technique. Can you explain a bit more about it?
So I don't think that there is a specific no, like a hard no from Apple. It's a typical usage scenario for push notifications. So you can have push notifications that show like a banner, like when my wife, or someone messages me. But you can also have silent push notifications that arrive to the device without carrying anything and allowing you to wake the app up and do something in the background very shortly. So it will not kill your battery. You can also have silent push notifications that have a JSON payload attached, right? So it's a way to communicate with the app in a very lightweight way, so that you can perhaps not wake the app up in the background, but just get this JSON that is somehow crucial to the app. But it's not banned. It's a typical practice. Apple, for a very long time, they have banned marketing push notifications. Now they open it up, so now you can basically shove promotions down people's throat through push notifications. So you can say, hey, there's this new subscription, whatever. But what you're talking about is completely allowed, and it's a typical practice. What I was trying to convey is don't rely on it, because you have virtually no guarantees that this push notification will make its way to the phone. And once it makes its way to the phone, you really have no guarantee how much airtime you'll get. But it's a great feature if used wisely, and treated again as a nice to have, not as a critical way to deliver stuff to the phone.
Okay, got it. Thank you. And the second question, if I may, about the business. So you've talked that at one of your previous company, you had to fire the full department of 200 people. So,
I didn't. So it was a client of ours.
It's not like it was the story. So I captured it like it's about the house that is easier to burn down than clean up. Can you tell a bit more? What kind of problems did they face?
So they were building 2 devices. It was a health division of a Fortune 500 company, and they kept throwing a lot of engineers. So basically, most problems were answered by pushing more people towards the problem, right? And it's never the solution. It never works. So they had fundamental problems with pairing, with retaining the connection, with crashes. I mean, I get that crashes happen, but if you're building a medical device and that device was supposed to be a medical device, you really have to pay a lot of attention towards, QAing the heck out of this. So, after a while on the market, the board, it's a calculation, right? So they decided that it's hurting them more to have these devices on the market than the revenue that they bring. Sadly, yes. I have a question over here.
Yeah, so I also have a question because on the previous slide, which you showed, there was a lot of negative feedback when a company which had a great app working started implementing smart things. So my question would be, which milestones should a startup achieve in order to start bringing some smart things to the table? And is it even worth the risk going into that direction?
So it's a product question. It's not an engineering question, it's a product question. It really boils down to the risk. So how much risk appetite do you have? Because building out this smart solution, it's a heavy lift, right? So building an app, building, like the little piece of hardware that sits in your device, there's firmware. It's a lot of complexity, as the title says. So I think it's a decision on your end to weigh the potential risks, like you've seen on the slides, getting brand damage, a lot of things can go wrong, and how much you can make by providing extra value by introducing some smarts to the product. It's a very similar question with the AI now, right? Like everybody does AI, but does it really bring a lot of value, right? Do I really need to have, my emails summarized by 30 different tools? I'm not sure, right? I'm not sure if I answered your question.
Do we have any other questions? Yeah.
One more.
Hey, thanks for sharing this kind of list of underestimated things in IT world. So do you have at least something which people usually tend to overestimate in such projects? Like something which people should not pay so much attention at first?
That's a good one. And I'll say this. There is, in startups primarily, there is a lot of effort that goes into planning, like the people sit and they plan, and not a lot of effort that goes into shipping. You should, once you validate your hypothesis that you have product market fit, or you have enough of a conviction to build something, start building. Ship often, iterate quickly. Don't spend time building 6-month roadmap, because it's going to change. So people get really focused on planning, but I would probably prefer them to sit down and start writing code and ship.